Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have cos 3x into cos 2x, right? So looks like we cannot jump directly to an answer. We have been given dy by dx. So my y is nothing but integral of this particular expression cos 3x cos 2x, right? I know that we can express this using the sum product formula, but then what I believe is that sum product formula is not very common when it comes to its usage in trigonometry. And let's try and simplify this expression. We will not apply the sum product formula directly, but then we will try to bring it to that particular format using some of the common identities that we know. I'm going to express my 3x as 2x plus x, right? And when I do that, what happens is I get a cos of 2x plus x into cos 2x, right? So what is my cos A plus B? My cos A plus B is nothing but cos of A into cos of B minus sine of A into sine of B, right? And then remember that we still have our cos 2x, right? And I'm going to expand this further. I have my cos 2x cos x into cos 2x, which is nothing but a cos square 2x, right, times cos x, right, minus I have a sin x into sin 2x cos 2x, right? So let's write that down. I know that my sin 2x into cos 2x is nothing but 1 by 2 times sin 4x, right? I'm going to leave it as it is, and I'm going to come to the next line. I know that my cos square 2x into cos x, right? And this is where I want you to see how I can connect the first part of this expression cos square 2x into cos x with the second part of the entire expression, which is having a half of sin x into sin 4x, right? I know that my cos 4x, right? Let me write down this identity here. My cos 4x equal to 2 times cos square 2x minus 1, right? So this is what we have. I go back to my expression. So let me highlight this particular identity in, say, yellow. We're going to use this in the above expression. I come back to my expression and I know that my cos square 2x is now half of 1 plus cos 4x, right? 1 plus cos 4x times cos x, right? Minus half of sine x into sine 4x, right? Which means I can rewrite this expression as half of cos x, right? Plus, observe this very closely, I have half of cos x into cos 4x minus of sine x dot sine 4x. And what is this? This is something very familiar to us. This is of the format cos A cos B minus sine A sine B. And what is that? It is nothing but a cos of A plus B, right? So I have half of cos x here. I retain it as it is because it's in a format whose antiderivative I know. And with respect to the second expression, I know that it is of the format cos A cos B minus sin A sin B, which means that it is a cos of A plus B. And my A here is x and my B here is 4x, which means I have a cos of x plus 4x, which is nothing but a cos of 5x, right? Now I can re-express my y, which was originally integral of cos 3x cos 2x dx. is nothing but integral of, and I'm going to pull out the half. I have integral of cos of 5x plus cos of x dx, right? I apply the sum rule. I can break this down using the sum rule, right? And I'm going to skip that step because by now you're quite familiar with what the sum rule is. And my answer to this problem is half of integral of cos 5x dx is nothing but sine 5x by 5. And then I have integral of cos x dx, which is nothing but my sine x, right? So there we are, and not to forget my constant. And folks, if you've not understood integral of cos 5x dx is equal to sine 5x by 5, please take a look at the description. This is a function of the type f of ax plus b. And when you know the integral of f of x, how do we arrive at integral of f of ax plus b is something is what I've written down in the description of this video. And at the same time, I've solved a few problems in the past. I request you to take a look at some of those videos and learn this better, right? There we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.